Hello, and welcome to the second virtual Philip J. Currie Dinosaur Museum speaker series. Here we will have paleontology guests call in for a presentation on science, fossils, and prehistoric animals, where the public will be able to ask questions both here at the museum and live on YouTube. For the viewers at home, you can leave your questions in the comment section, and I will read them to Dr. Zazula at the end. First off, we want to acknowledge that we are on the homeland of the many diverse First Nations and Métis people whose ancestors have walked this land since time immemorial. We are grateful to work, live, and learn on the traditional territory of Treaty 8. Today, our special guest, Dr. Grant Zazula, is joining us all the way from Whitehorse in the Yukon. He will be presenting the last interglaciation in Beringia, what Yukon fossils tell us about past global warming. Dr. Zazula has a Bachelor of Arts and Master's degree from the University of Alberta in anthropology, where he focused on Yukon Ice Age paleoecology. He went on to Simon Fraser University to complete his PhD in biological sciences with Rolf Matthews, studying permafrost preserved plant remains held within Pleistocene nests of Arctic ground squirrels. For this, he was awarded the Dean's Graduate Convocation Medal in Science. Only 6 weeks after defending his PhD, Dr. Zazula was hired by the Yukon Territorial Government to head their paleontology program in Whitehorse and has continued to run the program for 13 years. Thank you, Dr. Zazula, for joining us virtually today. And with that, I will hand the floor to you.
Excellent. Well, thank you so much for that introduction, and thank you all for joining me today. I'm just going to share my screen to get my slide presentation up. So I'm up now, so I'm assuming everyone can see that. And yeah, so I'm as was mentioned, I am the paleontologist for the Yukon Territorial Government, and I've been in the position here for almost 14 years, since 2006, and I oversee paleontological research and resource management and public outreach. And largely a lot of our work is to do with the amazing record of Ice Age mammals that is found in the Yukon and in Beringia. And that's what I'll be talking to you a bit today. But I'm going to not kind of be focusing on the kind of classic cold conditions of the Ice Age. I'm going to talk to you a bit about some of these brief global warming episodes that were experienced during the Pleistocene that can, I think, can tell us a bit about how animals may respond to contemporary global warming scenarios. So with that, we'll launch in here. Okay, let's see. There we go. So as was mentioned, I am in Whitehorse, Yukon. It's the capital city of Yukon Territory. I hope if you're out there listening, let us know if you've ever been to Whitehorse, and or if you're ever planning on coming here. I'd love to be able to host you and show you around. It's a wonderful place. It's not that far up the Alaska Highway from Grand Prairie, where the Philip J. Currie Museum is located now. And of course, we're next door to Alaska. Fairbanks, Alaska is our next metropolitan neighbor, and that's about 12 hours away on the Alaska Highway. So Fairbanks and Whitehorse are close neighbors, but not that close in geographic kind of space. Whitehorse is a small city. We're about 30,000 people, and of course, at this latitude, it's winter for 7 months of the year. Right now, as I'm speaking, we're having currently one of our nicest days of the year. So as soon as I'm done speaking to you today about the Ice Age, I'm going to go outside and try to get a bit of a suntan. So there's about 30,000 people in our small town of Whitehorse. But of course, this is a major wilderness area that contrasts with probably about 70,000 moose that live in the Yukon. So, it's a place where it's an interesting place to study large animals because, as most people live in urban centers, never get a chance to actually encounter wild animals and large megafauna in their lives. But any given day, it's really simple to see moose or bears or wolves out and just behind my house. In fact, the other day we saw 2 coyotes, taunting my dog. So it's a very wildernessy area. So I work with the Yukon Territorial Government, and the paleontology program is aligned with the Yukon Beringia Interpretive Center, and that's our local museum that's dedicated to telling the story of the Ice Age and to tell stories that come out of the research that we do on fossils, predominantly Ice Age fossils from the Yukon and Alaska. So just to situate ourselves, because this is a paleontology talk, and I know this is a dinosaur museum that is hosting me today. So most dinosaur scientists think that we're just gardeners. We're only looking at the top superficial layers, and that's really true. If we look at this diagram showing Earth history through time, the Pleistocene is really the most recent geological period that paleontologists study. It began about 2.5 million years ago and ended around 10,000 years ago. So really, you know, a lot of people in the paleontology world are focused on things like dinosaurs. But for me, I'm more interested in looking at how changes in the recent geological past can tell us and how they affect, provide information in terms of what may be happening in terms of modern day ecosystems in the north. And so in that way, the Yukon is perfectly situated for those kind of studies. So this is a very, for those of you not in the quaternary sciences or that know a lot about Pleistocene climate change, this is a fairly typical climate record, global climate record that we use as sort of a kind of a benchmark for the Pleistocene, the Ice Age. So if we look at these wiggles that go back and forth and back and forth and back and forth, here, that's showing the oscillations, the regular oscillations of climate that happened over this 2.5 million year history since the Ice Age began. And this climate oscillation is a real regular feature of the Pleistocene, and where we go from cold periods to warm periods back and forth over many thousands and thousands of years. But if we look at this over the long term, over that 2.5 million year history that we call the Ice Age, about 90% of the time it was colder than it is present. So we call these periods glaciations. So these are kind of the typical stereotypical Ice Age conditions that most of us are familiar with if we've watched, you know, cartoon movies like the Ice Age and see, you know, glaciers and woolly mammoths running around. But there were also brief warm periods during the Pleistocene as well. And we call these periods interglaciations. So these happened at regular periods, regular oscillations throughout the Pleistocene, where we get conditions that are very similar to what we're experiencing on Earth's system at present. So generally warm conditions like we are experiencing today. But these are very rare. They don't happen very often during the Pleistocene, but they occur at regular intervals. And it's with that, those regular warm periods that occur in between glaciations that I think can tell us a lot about the future, because at present, we're actually living in one of these interglaciations that began about 10,000 years ago. So if we look back at a map of North America about 20,000 years ago, this is what we'd see. That white area is continental ice. It's continental glaciers that covered most of Canada. But me as a Yukon, or someone that lives in the Yukon, it's a really exciting place to be in terms of studying the Ice Age, because when most of North America, or the northern parts of North America, most of Canada were covered by ice during the last glaciation, Yukon escaped glaciation. It was always an ice-free area in the interior. And that's the same goes with Alaska as well. And those ice-free areas of Yukon and Alaska were connected to Siberia via the Bering Land Bridge. So that was that land between the continents that allowed for dispersals of animals back and forth between the old world of Eurasia and the new world of North America and South America. And this area, although it was incredibly cold during the last glaciation, it didn't support glaciers, which is always quite strange to think about, because thinking about northern latitudes today, why wouldn't there have been glaciers in a place like the Yukon, the interior of Yukon, during the last glaciation? And largely it's a story of aridity, because you need two things to build glaciers. You need cold, but you also need moisture. And we feel that in Yukon and Alaska during the last glaciation, it was a moisture precipitation limited environment. So if you think back 20,000 years ago, it was incredibly cold. The sea was probably covered by ice all year round. And then any moisture that was coming off the North Pacific would have got caught in these coastal mountains here, the Pacific moisture getting caught in the coast, forming montane glaciers. But by the time that air from the Pacific reached the interior, it was incredibly dry. So the interior of Yukon and Alaska were in a snow and rain shadow during the Pleistocene. Therefore, it was too dry to support the growth of glaciers. So this area of Beringia is a real matter of interest for a lot of biogeographers and paleontologists because it's really the only terrestrial connection, or one of the during the Ice Age between the Old and New Worlds. But even prior to the Ice Age, it was a major terrestrial connection going back to the Cretaceous. So we know that dinosaurs were dispersing across the Bering Land Bridge during the Cretaceous as well. So this area, because it was never glaciated, the environmental records of the Pleistocene weren't eroded and destroyed by glaciers. So it's a really interesting place to study deep records of environmental change. And because it was never glaciated as well, it was a place where animals could live throughout the Pleistocene. So animals that, say, may have been living in a place like Grand Prairie, Alberta during the Pleistocene had to go somewhere when the glaciers were advancing across that landscape. So some went north into Beringia, some went south. So it's a refuge. It's what we call a refugium for plants and animals during these cold periods of the Ice Age. So as I said before, that because of that land bridge forming, it allowed the connection between animals and plants between these different continents. So this is a map of the Yukon, and I'm going to go over some of the areas that we do a lot of our field studies in. So of course, Whitehorse is in the southern and central part of the Yukon Territory. And one of the major areas that our field program's based out of is in Dawson City, so the homeland of the famous Klondike Gold Rush. And that's about a 6-hour drive up the Klondike Highway from Whitehorse. Dawson City is a wonderful place. In the summer, there's about 2,000 people that live there. In the winter, it's a little less population because people seem to gravitate towards Dawson City in the summer because it's a great place to be, to experience the midnight sun in a small, cool town that holds this kind of gold rush character. This is the landscape around Dawson City, these rolling hills and the Klondike Plateau. This is a shot from the fall time, so you can see the deciduous leaves turning yellow. But in the middle of the screen, you can see at the valley bottom, this is small-scale gold mining. So what we call placer gold mining that occurs in the valley bottoms around the Klondike gold fields near Dawson City. And this has been going on, this sort of small-scale gold mining has been occurring there since 1898, when the original gold rush was happening. So the gold was first discovered in the Yukon in 1896 in a place called Bonanza Creek. And there were some folks, George Carmack was an explorer of the time running around the Yukon trying to get rich. And he had some First Nations Indigenous people with him, Kate Carmack and Skookum Jim. And it's thought that Skookum Jim first found this nugget of gold sitting in Bonanza Creek. And of course, the Indigenous people at the time didn't have much relationship with gold, so they didn't really understand its value to European people like George Carmack. So when he pointed out this nugget of, when Skookum Jim pointed out this nugget of gold to George Carmack, of course, this was huge because they said at this time you could walk around these small creeks in the Klondike goldfields and literally pick up nuggets from the creek bed. It was so rich in gold, and it spurred off a massive gold rush. So this was, in this area before the gold rush, was the homeland, and still is the homeland of the Klondike Gwich'in people. This is what Dawson City would have looked like in 1896. It was a small fishing camp, home to a small family of Klondike Gwich'in. And in 1898, these people would have been fishing there in their small fish camp, and they would have looked up and they would have saw 40,000 people descending upon their town or their little area, their little village, in the summer of 1898 with all these gold stampeders. So Dawson City went from a little fishing village to a city of 40,000 people overnight in the summer of 1898 and formed the town of Dawson City. So it was a massive influx of white people into the community, totally changed the lives of Indigenous people in the region, but really kind of spurred off what we would call the modern development of the Yukon Territory. So people came from all over the place, California, Seattle, all over the Western US in pursuit of gold. But of course, I think once they found the gold, they immediately started finding the remains of Ice Age animals. So this is a spectacular shot in the late 1800s of 3 individuals with this amazing skull of a woolly mammoth with tusks. And And of course, these people probably weren't highly educated. So when they found the skull and tusks of some sort of ancient primitive elephant, they must have been blown away, because to find the remains of elephants in the subarctic is something they probably didn't expect, but was certainly something they spoke a lot about, because they told a lot of people. Newspapers were printing articles about the fossils of the Yukon, and many institutions around the world sent expeditions like the MNH and the Paris Natural History Museum. So these massive journeys to get over to Dawson City and elsewhere in the Yukon to go study and collect fossils to bring back to their museum collections. So that relationship between gold miners and paleontologists and scientists still continues on today. So this is a typical scene we encounter when we go visit a gold miner in the Yukon. So there's skulls and teeth and bones and tusks, and these things are so commonly found in these gold mine operations that they're almost like the bycatch, if you will, if you want to compare it to a fishing vessel. So these are all the things that they find as they're digging through the frozen ground in pursuit of gold. So a lot of the fossils that we find in the Klondike gold fields are dominated by the mammoth fauna. So these animals that lived during these cold, dry times in the Yukon and Beringia. So we envision these times during the Wisconsin Interglaciation. And this is a climate curve going back to about, we see the last 150,000 years of Earth history, but this time period between about 10,000 and 60,000 years ago is what we call the Wisconsin Interglaciation. And for most of our paleoecological reconstructions, we envision this to be a very cold, dry, almost treeless steppe tundra environment. So an environment dominated by grasses and other types of grassland plants. And this is the perfect type of environment to support large-bodied grazers like our friend here, the woolly mammoth. So woolly mammoths are kind of the iconic animal of the Ice Age. They were probably consuming massive amounts of grass every day. And this is a typical part of a skeleton that one of our gold mining friends here, Guy Favron. So these are so commonly found out of the gold fields that miners who find them, they largely are very happy to put them aside and wait till paleontologists come and retrieve them. And they're very curious about all of the different types of remains that they're finding as well, because they're there in pursuit of gold, yet they find all these fossils for us. So they're quite excited to be able to work and learn about what they're finding as well. Here's a typical molar. We can see that occlusal surface on the top, indicative of a typical large mammal grazer, that flat grazing surface of the occlusal surface. So these are teeth molars that are well adapted to grazing and eating huge quantities of grass. One of the other animals that's most common during the cold periods are horses. So these small-bodied horses that were very common throughout Beringia during the Pleistocene. We know that genetically, these are animals that are very, very closely related to today's domestic horses. So we can even say with confidence now that the population of horses that was in North America, that went extinct in North America about 12,000 years ago, which survived in Europe and Asia, and later domesticated in places like Central Asia, were from the same stock of animals that were in Beringia. So Beringia is really the source of all later domestic horses throughout the world. This is one of the most spectacular fossils that's been found in the gold fields. And this is the skin, the mummified skin of a 30,000-year-old horse. So because of that permafrost, we can get the preservation of true soft tissues and mummies of some of our animals. So this is a 20,000-year-old horse, 30,000-year-old horse. We can see the tail with hair on it. We can see articulated leg bones with skin and muscles and ligaments still attaching, because that permafrost is like a deep freeze. So when an animal dies and doesn't get consumed by scavengers and doesn't rot away, it has an opportunity to become mummified. Steppe bison, these ancestors of living bison, are the most common animals that we find in the Yukon. And largely, these are just large bison with huge horn cores. So the only thing that's really separating them from today's bison are these massive horn cores. And you can see here these huge curled horn cores. And over 80% of the fossils we find in the Yukon are from these large steppe bison. So we also have a fair number of carnivores that are living in Beringia during the late Pleistocene, during the cold periods as well. And I'm going to breeze through them because we're going to be specifically talking about animals of the warm period. But of course, there's some very spectacular carnivores that we had up here that we have fossils of. Animals like the scimitar cat, which is a distant relative of the saber-toothed cat that's found in places like southern Alberta and further south in North America. We had American lions, which lions were all over the globe during the late Pleistocene. They're found in North America all the way to Mexico, Eurasia, Africa. So lions had expanded all across the globe during the Pleistocene. And of course, we can only really find them in zoos and a few nature parks in Africa now. Short-faced bears, which are these huge North American bears that are now extinct. It's thought they were completely carnivorous, and in some areas like the north in Yukon and Alaska, they may have been completely scavenger bears. They weren't predators at all, and more work is being done on those. And one of our most common carnivores is our wolves, and so this is a shot of one of our amazing mummified wolf pups that was found. That's over 60,000 years old. It was found at a gold mine in 2016, and we just submitted a paper to Science yesterday about this. So we have a completely mummified carcass of a 7-week-old gray wolf that lived and died during the Pleistocene. And we're really excited with a mummified animal like this because we can learn so much about its life through stable isotope research and genetics and all kinds of things like that. We also have a new cat species in Beringia that we're just writing up right now, and I'm going to be, I won't say too much more about that, but it's really cool to have a new cat in Beringia that's living in the high latitudes of North America that we know is found in other areas of southern North America as well. But just to get into my whole discussion about the last interglaciation, I think one of the things that we need to talk about are artistic renditions of paleontology. And I know paleo art is a massive thing now, and everyone wants to have a beautiful image to go along with their new fossils. But sometimes, especially in the early days, some of these ancient murals led us down scientific problems, down the path of scientific problems. Because, for example, this was a reconstruction done of central Alaska that was done for the American Museum of Natural History in 1975, and it shows this amazing association of all these animals living together in harmony. It's almost like Noah's Ark was just stopped on the Gulf of Alaska and let all the animals out, and they're living in peace and harmony. But does it really make a lot of scientific sense to have all these animals living together at the same time on the same landscape? And when we started picking this apart, it raised a lot of questions. For example, did animals like giant ground sloths live at the same time as people? Because in this mural, it shows hunters hunting a ground sloth in Alaska. Did that really happen? What about camels and moose and mammoths? Did they all occupy the same habitat? What can we do to sort that out? Let's try to tease this illustration apart and see if it makes sense scientifically. So again, going back to our climate curve of the last 150,000 years, we can see from top to bottom going down in time. We can break this up into basically 3 major time intervals. So the Sangamonian interglaciation, one of these warm periods I talked about earlier in my presentation, was probably the last time on Earth's history that it was warm as it is today. So when we look back about 125,000 years ago, climates were as warm or maybe even warmer than they are on Earth today. So conditions are very different than what followed during the Wisconsin glaciation when it got incredibly cold, because around 20,000 years ago, it may have been one of the coldest periods over the last several million years on Earth's history. So those dramatic changes from this warm interglaciation to this cold last glacial maximum must have had major implications for large mammals at the time. Then, of course, about 10,000 years ago, at the end of the Ice Age, we have the present-day warm period called the Holocene. So this climatic framework can help us frame our paleontological research and try to sort out when different animals are living in Beringia. So to talk about the last glaciation, we're going to go to the remote village of Old Crow in northernmost Yukon. And this is a fascinating community where the Wundtik people live. And this has been a place where scientists have been coming for over 100 years to study Ice Age fossils. This is the typical environment around Old Crow. So the kind of tundra taiga transition, where we have all these thaw lakes and stunted spruce forest and these large rivers that are carving these amazing outcrops of Pleistocene sediment. So this is a place where the Smithsonian Institution sent an expedition in 1904 and 05, and they were so amazed by the wealth of Pleistocene mammal fossils found on the river that it spurred off interest in this region for many, many years, and many scientists followed in their footsteps. And even the New York Times in 1913 reported on a camel fossil that was found along the Old Crow River. And that's quite strange, of course, because people always associate camels with deserts. So people were trying to come up with some explanation about how camels could have lived in the Arctic and Yukon. This is the fossil camel that was found by Madrin, and later described by Hay. So this is now at the Smithsonian collection. It's one of these cool fossils from northern Yukon that was found in the historic era. And as Madrin said in 1905 and 06 or 04 and 05, there's fossils found all over the river. So you can see our camp in the background. And this is like a few minutes of collecting these bones and fossil teeth and tusks alongside the Old Crow River. We worked very closely with the indigenous people of Old Crow, the Wundtik First Nation. And, they have this long history of these animals, because these are people that have been living on that landscape for thousands of years, going up and down the river and finding bones and fossils of these amazing animals. So it only makes perfect sense that they have really interesting oral histories about the transition from these giant beasts of yesteryear to these smaller animals that we have today. So interesting cultural explanations for the fossils that they were finding. So I'm going to take you to a locality called Chi-Chi's Bluff on the Porcupine River, just downstream from Old Crow on the way to Alaska on the Porcupine River. And you can see these bluffs of amazing Ice Age sediments. And these are about 50 meters high, and they're quite fun to work on, sometimes dangerous, but they provide a lot of interesting information. So you can see we do a lot of canoeing and boating up and down the river, searching for fossils, and then studying the stratigraphy exposed along these bluffs. And about 3/4 of the way up these large bluffs on the Porcupine River and the Old Crow River, we typically find the bed of the last interglaciation. So we can see where that ice axe hammer is here. We can see all these twigs and sticks and things like that. And those are all twigs and sticks deposited within the time period of the last interglaciation when it was warm. So but we also see beneath it, we see these wisps of white, and those are volcanic ash. So there are tephra coming from volcanoes in Alaska. So we know throughout the Ice Age that volcanoes in Alaska were exploding and depositing their ash downstream, downwind into the Yukon. And they provide very important stratigraphic time markers for the fossils that we study. So we have a couple of these major eruptions that happened during the Ice Age, the Old Crow tephra and the Dawson tephra, which are two of the major eruptions. The Old Crow tephra erupted about 140,000 years ago, and it comes from the Aleutian Islands. So this is a massive volcanic eruption because we find it, several thousand kilometers away in the Yukon. So going back to the last interglaciation, we also find the evidence of these small trunks and tree stumps that are found in these last interglacial sediments as well. So based on its stratigraphic position with the Old Crow tephra here, that's about 140,000 years old, we know that these twigs and logs and stumps that are found in the sediments have to date to about 125,000 years ago, which we can stratigraphically correlate to this interglacial period that happens at that time. So in this interglaciation is also evidenced by a lot of fossil pollen. So we do a lot of fossil pollen work within our sediments, and we can see that when the Old Crow tephra is being deposited around 140 or 150,000 years ago, it was largely a cold shrub tundra environment with a lot of birch and a lot of alder, grass, and sedge. But after the eruption of the tephra, where we find these spruce trees and logs, we also find a lot of pollen of spruce trees, so signaling the return to boreal forest conditions of the last interglaciation. So these are the typical types of environments we'd find today in the Yukon. So and these kind of sites are stratigraphically correlated all across the interior of Alaska and Yukon, showing this pronounced warm period with the return of the boreal forest back to Alaska and Yukon. This last interglaciation was first noted by a geologist named Troy Payway from the University of Alaska. And he talked about how in sites in Alaska where we have these evidence of huge trees, he talks a lot about the permafrost thawing at this time. So that's quite an interesting observation because in terms of the present day global warming, we're also quite concerned about permafrost melting. So we can see here, this is the site of Eva Creek in central Alaska. We can see this big log that's sticking out of the bluff. That log is about 125,000 years ago. And we can also see the stratigraphic correlation with the volcanic ash bed here. So this is a reconstruction of what central Alaska would have probably looked like during the last interglaciation. It would have been more of an open spruce forest with tundra. So very typical of what we'd see there today. We know that based on the study of fossil beetles, which have very important paleoclimatic indicators, that conditions across the whole Arctic were quite a bit warmer during the last interglaciation. So in places like Alaska and Yukon, temperatures were higher by about 0 to 2 degrees. There's places in Greenland that are up to 5 degrees warmer, places in Siberia up to 4 to 8 degrees warmer. So beetles have this very important temperature range that they can live in. And when we find them in other areas, it tells us that the climates of those areas must have been different. So we can see based on beetles that the whole Arctic had warmed substantially 125,000 years ago during the last interglaciation. There's also quite a bit of evidence for this permafrost thaw. So we can see the sloughing of sediments, the cryoturbation of sediments, marking that shallow thawing of permafrost throughout the Arctic at that time. We see what this looks like in the present day. So in the present day environment, when we have permafrost melting along rivers, we get huge mass movements of soft sediments. And in some regards, this is on the Old Crow River today. Some of these soft sediments can melt and almost block the river. So they cause major environmental change. So we also know that with permafrost melting, with warming climates, we also get glaciers melting. And with glaciers melting, you get sea level rise. So this is a climate curve showing a number of these different interglacial periods. The current interglaciation, the last interglaciation about 125,000 years ago that we call MIS or marine isotope stage 5. And then we can also look at stage 7 here, stage MIS 11. So these are all these various warm periods. And every one of those warm periods is also marked with pronounced sea level rise. So we use a number of geological techniques to try to estimate sea level rise during these periods. But if we have, some of the estimates show that if you have 50% ice reduction in Greenland, the global sea level rise globally will go up about 3.5 meters. So that's probably what happened during the last interglaciation. We see about a 50% reduction in Greenland. So thinking about future climate change, these are the sort of sea level changes that we could experience. You know, some of these estimations showing contributions from Antarctica predict that we could have sea level rise of up to 9 meters with current interglacial warming that's happening. So the interglaciation had major effects on animal populations around the world. And one of the greatest examples of that is London, England. So under Trafalgar Square, there were the remains of hippos. So African hippos found in England during the last interglaciation. So seeing the northward movement of some of these more temperate taxa moving up into the northern latitudes, because the warm conditions and general environmental change allowed the facilitated the movement northward of some of these animal populations. So let's talk about some of these animals of the warm interglaciations in Beringia, so in Alaska and Yukon. And what we know about some of these animals has always made us think that, man, the ecology of these animals doesn't quite fit with the general mammoth fauna, the mammoths, the horses, the bison. They don't seem like they could live in the same types of habitats, largely because of their things like their teeth and other things that we know about their ecology. And the best example of one of these interglacial animals are American mastodons. So we have 2 different types of elephants that lived in Alaska and Yukon during the Pleistocene. On our left here, we have woolly mammoths, and woolly mammoths were found during the cold periods because they were grazers. They ate tons and tons of grass. They could eat 200 kilograms of grass a day. So their teeth really reflect, the morphology of their teeth really reflect a grazing diet. And that really contrasts with their cousins, the American mastodons. So we can see these high cusps on their teeth, these molars, which are very typical types of teeth or molars that you'd found in a browsing animal. So an animal that eats small shrubs and small trees, small branches off trees. So these are animals that are eating very different types of food. So it's likely they either partitioned the environment and lived at the same time in different habitats, or did they live at different time periods of the Pleistocene? And we'll get to that in a few seconds. We just know that they're very different elephants. Another type of animal that was very common in the Yukon during interglaciations probably were the Western camels. So a lot of isotopic studies and other studies that have been done with micro wear on their teeth tells us these were camels that were browsers. They're not grazing camels that one would think of camels sort of living in an open treeless environment, but that's actually not the case. These were animals that were probably browsing small shrubs and trees, just like their friends, the American mastodons. They're also very rare in Beringia. We only have a very small number of their fossils ever found here. Ground sloth. So this is the Jefferson ground sloth that's famous for, Thomas Jefferson describing and talking about them back in the old days. So Jefferson's ground sloth, another one of these strange animals that has its evolutionary roots in South America, that it makes its way to North America and then expands all the way to Alaska and Yukon during interglacial periods. So these are animals that their teeth are really well adapted to stripping deciduous leaves off of twigs and trees. So these are all not animals that can graze off grassland environments like a woolly mammoth. Another typical interglacial animal is the giant beaver. And this is my friend Brent here. He's a geologist and showing that although one may love to believe that a giant beaver may be a carnivore with those huge incisors, they're actually not. Unfortunately, they're another herbivore. What we can see the size difference between these giant beavers that we have, and this is a specimen found from the Porcupine River by Dick Harrington back in the old days, 1968, showing the comparison with a modern day beaver jaw. This is the size comparison of our friend Justin Beaver. So giant beaver is just about the same size as Justin Beaver. So with all these strange animals, giant beavers, camels, mastodons, and ground sloths, a lot of their aspects of their ecology tells us that they were probably animals that couldn't survive in cold, dry conditions of the Pleistocene. And when we did a bunch of radiocarbon dates on them, the radiocarbon dates all came back non-finite. So that tells us, if you're not familiar with radiocarbon dating only works to about 50,000 years ago. And then its limits are about there. You can't measure radiocarbon past 50,000 years ago. So all the dates on all these animals always came back older than 50,000 years ago. And because of the sites and the stratigraphy that we find these sites, these specimens at, we believe that they probably date to the last interglacial periods, because we're not able to actually put direct dates on most of these fossils. We presume that they're dating to older than 50,000. They're all animals that seem to have teeth and other morphology indicative of browsing in a forested type environment. It tells us or suggests to us that they probably weren't living during the last glacial maximum. They were probably living when it was warm in the Yukon. So we've reconstructed these animals to be browsers of the high latitude interglacial forests. So this warm period that we call the Sangamonian that started around 125,000 years ago, when conditions in Alaska and Yukon were very similar to today, that we had these types of animals running around the boreal forest in the southern parts of the tundra of Alaska and Yukon. So, and this is an interesting situation, because we know these are animals that were widespread all across North America that ventured their way to Alaska and Yukon at some point during the Pleistocene. And we've been able to, using this information, putting a model together of how these animals lived in Alaska and Yukon. And we know these are all animals that are endemic to North America. So these are all species that are only found in North America. They never were able to disperse to Asia or Europe via the Bering Land Bridge. So they had all their evolutionary roots in much southern localities in North America. So we think that at some point during the last interglaciation, when it was nice and warm, sunny temperatures, boreal forest, lots of food to eat, that they were almost like American tourists. Let's go visit Alaska for the summer and let's go see what it's like up there, because conditions were so warm that it enabled them to be able to expand their populations all across the continent, even into the high latitude regions of Alaska and Yukon. So they were spread all the way to the coast of Alaska during the interglaciation. And then what happens after about 75,000 years ago, after all these animals achieved their maximum biogeographic range in North America, the glaciation hits them. So the Wisconsin glaciation begins around 60,000 years ago, and conditions for these animals became much more difficult. So at first we have the expansion of glaciers covering most of Canada, probably separating these populations. So certainly the formation of a large ice sheet throughout most of Canada caused the biogeographic separation between southern populations and northern populations. So first of all, that breakup of the population probably caused a reduction in genetic diversity for these species. And furthermore, the conditions in the environment would have changed. So instead of this nice, warm, boreal forest in Yukon and Alaska, conditions would have become more like steppe grasslands and tundra. So the animals would have had to try to adapt from boreal forest conditions to open treeless conditions, and they just weren't able to. So it's likely they suffered local extirpation in Alaska and Yukon around 75,000 years ago. So it's really the return to cold conditions that caused their local extinction in the high latitudes parts of Beringia. And then around 11,000 years ago, at the end of the Pleistocene, we know these are species, mastodons and ground sloths and camels and giant beavers. They all survived till about 11,000 years ago in areas to the south in the main parts of the United States. And they survived right to the end of the Pleistocene until about 11,000 years ago. So first we see the reduction in their population because we see the northern population gets wiped out by the return to cold conditions. Then eventually at the end of the Pleistocene, it's likely the return to warm conditions, which causes their final extinction in the United States. So the other piece of the story is that we've recently done some really cool ancient genetic work on American mastodons. And this is a paper that's in press right now in Nature Ecology. And what we're able to do is look at the mitochondrial DNA from American mastodons from all the way from Alaska to Mexico. And one of the neat results coming out of this work is that we see two different populations in Alaska and Yukon. And they're two populations that are likely separated by a couple 100,000 years. So what this is telling us is that there was likely two major dispersals or migrations of mastodons northward into Alaska and Yukon. So at two different times, during two different interglaciations of the past, we see American mastodons moving from areas in the south in the United States all the way to Alaska. They get wiped out by cold conditions, and then they repeat that process again. So twice did we see failed migrations northward, and then local extinctions of mastodons in Alaska and Yukon, which is a really cool thing to show that repeated cycle of warming, creating the conditions for northward movements of animals, in this case, American mastodons, but then those migrations failing because of the return to cold conditions. So if we look at the history of population extinctions of some of these major large mammals in Beringia during the Ice Age, we can really break it up into two major periods of extinction. So one of those major periods of extinction began around 75,000 years ago, and that's after all these browsing animals migrated northwards because of the warming conditions, the warm climates, and the forests that occurred there, and they were likely wiped out when cold conditions of the last glaciation returned. So browsers all got wiped out around 75,000 years ago in Beringia, even though they held on and survived till the end of the Ice Age in areas to the south. And then we have the loss or the extinction of glacial animals, the animals that are adapted to cold, treeless environments like woolly mammoths and horses and bison, which all largely get wiped out around 11,000 years ago in Beringia. So cold adapted animals get wiped out after the end of the Ice Age when conditions turn warm again and the return of the boreal forest. So this trend of interglaciations and global warming has been occurring throughout the Pleistocene. But when we look at modern day climate curves of temperature changes over the last couple of hundred years, we can see that this climate in the most recent interglaciation of the Holocene, our present day interglaciation, we see these pronounced temperatures occurring in the last, say, 150 years as a result of human impact on the environment, the Industrial Revolution and atmospheric impacts. And what is this doing to our world? We can see that in many places, especially in the far north, we have permafrost boundaries moving further north. We can see permafrost melting. We see sea ice reduction. So these impacts of modern day global warming are being felt so much more pronounced here in the north than they are in most other areas. And it's causing huge concern for the people and the animals that live here. And what we're seeing now as a result of this climatic warming are the movements of many of these animal species northward. So we have a lot of animals like cougars, which are only spotted, the first confirmed cougar spotting in the Yukon was only a couple decades ago. White-tailed and mule deer are now moving north into the Yukon. Some of that may be the result of building the Alaska Highway, but a lot of it has to do with warmer conditions, especially warmer winters. So animals that could survive in warmer winters are moving northward. Grizzly bears are living all the way at the Arctic coast now and mating with polar bears. We have coyotes now in the Yukon, which were never here in the past as well. And skunks, which are an animal that only live in British Columbia and Alberta now, are moving northward, and they're likely to live in the Yukon in the next couple of decades. So this movement of animal populations northward is the sort of symptom of what we're seeing of global warming today. And one of the best analogs for this type of situation comes from the study of moose. So we can see that the northern limit of moose has been progressively moving further north because of the expansion of the tree line further north over the last 140 years or so. So we can see on this diagram that moose populations have been moving further and further north, all the way near to the Arctic coast. And this is the situation that we're seeing with moose today. But I think this presents a very compelling analog to what we were experiencing here in Alaska and Yukon during the Pleistocene interglaciation 125,000 years ago, where conditions, climatic conditions and environmental conditions are creating warmer climates, warmer winters, the expansion of the boreal forest, and a lot of these animals were able to move north 125,000 years ago in the same way that animals are moving north at present and are likely to continue to do in the near future. And of course, the poster child for a lot of this change that's happening in the Arctic now is polar bears. So what are we going to do as a population, as a people, a group of people? What are we going to do to stop this or to make it much less traumatic for animals living in the north today? So we have lessons from the fossil record. The fossil record of Beringia from the Pleistocene tells us that when warm conditions are established in the past, when we have pronounced global warming in the past, we will see animal populations change dramatically. Some of them will suffer, some of them will prosper, but it definitely will change and cause major disruptions for these communities. So I'm going to leave at that. This is a parting shot from the Old Crow River at one of the most important Pleistocene fossil sites in North America. It's called the Old Crow River Locality 11A. It was made famous by Dick Harrington from the National Museum. And we try to spend a few weeks here every summer, but of course, because of COVID-19, we're not there. But the flip side is that the fact that we're not doing fieldwork gives us so much more opportunity to be online and to share some of this information and to tell some of these stories to people from around the world. So with that, thank you so much for your time. And if there are any questions online, I'd be happy to answer them, but you can also see my contact information below, and I'm happy to answer emails or send you we have posters and booklets detailing some of the information and publications, and be happy to send you some if you get a hold of me. So thank you so much for your time, and thank you to the Philip J. Curie Museum for hosting me and for giving me this opportunity to talk to you guys today.
Well, thank you so much, Dr. Zazula. That was a fantastic presentation. We're now going to move on to our question period. Do we have any questions from the audience? No? Well, here's one. What is your favorite Pleistocene fossil you've discovered? Additionally, what is your favorite prehistoric animal?
Wow. The favorite fossil I've discovered? I think, to me, the first time when I was in the field and on the Old Crow River collecting fossils, systematically, it was a big boat trip. We spent something like 2 weeks paddling down the Old Crow River. And I remember the first time collecting the toe bone of an Ice Age giant camel. To me, that one really kind of clicked, that holding a camel bone at 70 degrees latitude and above the Arctic Circle just made me just realize how different the environment is now than what it was back then. And to think about all the changes that have happened in such geologically short time. We're talking about time periods only tens of thousands of years ago. And I think, to me, that's what really drives a lot of my interest, is when I look out at the modern environment in the Yukon and see the animals that we have here today, and to think about how it got to be the way it is, and how it got to be over such short geological time periods. So yeah, the first time I found a camel was a very exciting thing. But to me, the animal that I think is one of the coolest Ice Age animals are woolly rhinoceroses. And we know that woolly rhinoceroses only lived in Eurasia. They never made their way across the Bering Land Bridge to North America. And I don't know why. They should have been able to cross the land bridge. We should be able to find them. And I swear, by the time that I retire, we're going to find a woolly rhino in North America. And because of that, I got a woolly rhino tattoo from Chauvet Cave on my arm. And I think that's going to bring me good luck to be able to find a woolly rhinoceros. That's my hope, anyways.
Well, here's hoping. Fingers crossed. We got one more question, it looks like. Have you done any field work in Alberta? If so, whereabouts, and what'd you find?
Well, when I grew up in Edmonton, so I did my first couple of degrees at University of Alberta, and at the time I did my undergraduate and master's in sort of a double major with geology and archaeology. And I did mostly archaeology field work in Alberta, and one of the most exciting projects I had ever had a chance to work on was an archaeological site that was about 11 or 10,000 years old in Jasper National Park along the Snake Indian River, which is near the Athabasca River. And there's spear points and things like that, but no bones. And so I never had a chance to be out in the field collecting Ice Age fossils in Alberta. But I visited Dinosaur Provincial Park and spent lots of time in Drumheller, and seen lots of Alberta's amazing fossils. And I work very closely with Chris Jass from the Royal Alberta Museum, and they have a wonderful program of Pleistocene research there as well. So,
well, yeah, that's very cool. One person is asking, did you get a chance to do anything in BC? And again, what did you find?
Yeah, I've never done any field work in British Columbia for Pleistocene. Oh no, I have. Yeah, I worked on a dinosaur site with Rich McRae, who's a paleontologist, a dinosaur paleontologist, and we worked at a dinosaur trackway site. So he invited me to come and spend a week with him, and we camped, and it was near Hudson Hope, BC, and there were these amazing footprints of theropods and even sauropods and all kinds of other crazy dinosaurs that I don't know the names of, because when you're a Pleistocene guy like me, dinosaurs are all the same. But I think for you dinosaur people, mammals are all the same. But yeah, it was super cool to have a chance to work on that.
Well, that's fantastic. It looks like that's going to be the end of our question period, unless, oh, we have one last one. What you got?
Cool.
How about your brother? Yeah?
Sorry, I can't hear.
We have a question of what's the new species of that cat gonna look like? I don't know if you can answer that.
Well, it's got two giant horns, and it's got fangs that are 8 inches long, and it has 3 tails. It's really, really something cool.
Oh, that's fantastic.
And it's going to be striped. It's going to be striped like a tiger, but have a mane like a lion. So it's going to be like a horned, spiky-tailed liger.
I love that. You got one more? I think the question is, what fossils have you found in the Crow River?
Oh yeah, well the Crow River has some of the really most interesting species because like there's certain Pleistocene species that have the only record of them in North America or in Canada is found from the old Crow River. And although it's not a fossil that I found, there was 2 fossils found in the 1970s, and there's only 2 teeth that have ever been found in Canada of this animal, and it's a hyena. So there was a species called Chasmoprothetes, which is a running hyena. So it was probably a hyena that was able to run at high speeds, and it wasn't purely a scavenger like a lot of hyenas are thought to be. This type of hyena was thought to be able to pursue prey. And there's only 2 teeth ever been found in Canada, and they were both found in the old Crow River. So that was pretty cool. There's also really cool animals like we've collected Jefferson ground sloths, and when you hold a giant beaver tooth that's like 6 inches long in your hand that you just pull out of a river, it's pretty cool because giant beavers are just, I think it would be the best thing to be able to go walk around and see giant beavers still. So we find a lot of their fossils. There's also like, lions and scimitar cats. Scimitar cat teeth are pretty amazing because they're a little bit different than saber-toothed cat teeth in that they have serrations. So they're like a steak knife. So that's a pretty wild adaptation for predation as well. So they're only found in the old Crow River. So yeah, cool things like that, which are always fun to find.
That's amazing. Hopefully we can get up there at one point in time and get to collaborate. That's really cool.
Yeah, we're always happy to host people and take them out and collect fossils.
And any more? No? All right, I think that's the end of our question period. Join us next Saturday at 3 p.m. for our special guest, Dr. Jingmei O'Connor, and her presentation on the evolution of dinosaurian flight and the rise of birds. Thanks again for tuning in. Cheers.
Thank you. Have a good day, everyone.